Yeah, good morning, friends, and welcome back. See, today we are uploading the chapter 2 of our course, namely C Sharp programming and the .NET environment. So, yesterday or today, 2 days back, I had uploaded the first chapter. So, this is chapter 2 of C Sharp programming and the .NET environment. So, in this small video, again, we are in the introductory part only. In this video, we are actually discussing what exactly is the .NET solution. The last video, we described at length the scenario, the different scenario, which led to the evolution of the .NET environment. So in this video, we are actually introducing you to the concept of the .NET solution. So this is actually C# programming and .NET chapter 2 of 96. Yeah, let us have a good time listening to this video. Fine. Yeah, the .NET solution. We are now coming to the .NET solution. See, what exactly is the .NET? What is the .NET solution? So, in short, the Windows programming has been quite tough. We have already seen it. In short, the Windows programming has been quite tough. Full stop. The .NET framework is a radical and brute force approach to making our lives easier. To making our lives easier. Full stop. The solution proposed by .NET is change everything. See, it is very important to observe. The solution proposed by .NET is change everything. Full stop. Change everything I have put in within double quote. Full stop. The .NET framework is a completely new model for building systems on Windows family of OS, Windows family of operating systems, as well as numerous non-Microsoft OSs such as Mac OS and various Unix/Linux distributions. Full stop. The core features provided by .NET is outlined as under. The core features provided by .NET is outlined as under. See, look at it. 1. Full of interoperability with existing code. That's very important. Full interoperability with existing code. Existing COM binaries can interoperate with newer .NET binaries and vice versa. That's it. Existing COM binaries can interoperate with newer .NET binaries and vice versa. 2. This is very important. 2. Complete and total language integration. See, complete and total language integration. See, unlike COM, .NET supports cross-language inheritance. Look, it's very important. Unlike COM, .NET supports cross-language inheritance, cross-language exception handling, and cross-language debugging. That's great. Look, and cross-language debugging. Fine. Yeah, the .NET solution continued. We are continuing our discussions on the .NET solution. The .NET solution continued. Third point, 3. A common runtime engine shared by all .NET aware languages. Look, a common runtime engine shared by all .NET aware languages. One aspect of this engine is a well-defined set of types that each .NET aware language understands. That each .NET aware language understands. Full stop. The fourth point, 4. A base class library. a base class library. See, this library provides shelter from the complexities of raw API calls and offers a consistent object model used by all .NET aware languages. Yeah, a consistent object model used by all .NET aware languages. Full stop. Next, fifth point, 5. No more COM plumbing. No more COM plumbing. Look. No more I class factory, comma, I unknown, comma, I dispatch, comma, ideal code. Ideal is actually for interface definition language. Ideal stands for interface definition language and the evil variant compliant data types. And the evil variant compliant data types. Full stop. The sixth point. A truly simplified deployment model. See, under .NET, comma, there is no need to register a binary unit into the system registry. A binary unit into the system registry. Full stop. Furthermore, .NET allows multiple versions of the same star.dll dynamic link libraries .dll to exist in harmony on a single machine. To exist on in harmony. To exist in .NET aware. .NET allows multiple versions of the same star.dll to exist in harmony on a single machine. Fine. Yeah, the building blocks of the .NET platform. See, we are discussing a very important point now. The building blocks of the .NET platform. That is nothing but the CLR, see the CLR, comma, CTS and CLS. In bracket I have kept the CLR, comma, CTS and CLS. I will explain it one by one. The three key entities that's very important in the .NET platform are the CLR, comma, CTS and the CLS. CLR, comma, CTS and the CLS. Common language runtime, common type system, etc. Look, full stop. From a programmer's point of view, comma, the .NET can be understood as a new runtime environment and a comprehensive base class library. That's it. From a programmer's point of view, the .NET can be, it should be understood like this. It can be understood as a new runtime environment and a comprehensive base class library. Full stop. The runtime layer is properly referred to as the Common Language Runtime or CLR. The runtime layer is properly referred to as the Common Language Runtime or CLR. Full stop. The primary role of the CLR is to locate, comma, load and manage .NET types on your behalf. Full stop. The CLR also takes care of a number of low-level details such as memory management and performing security checks. Fine. Yeah, the common type system, that is CTS, the common type system or CTS. Another building block of the .NET platform is the common type system, that is CTS. Full stop. The CTS specification fully describes all possible data types and programming constructs supported by the runtime. Full stop. Understand that a given .NET aware language might not support each and every feature defined by the CTS. Full stop. Now look, the next. The Common Language Specification, that is CLS. The Common Language Specification or CLS. The Common Language Specification or CLS is a related specification that defines a subset of the common types and programming constructs that all .NET programming languages can agree on. Full stop. Thus, if you build .NET types that only exposes CLS compliant features, you can rest assured that all .NET aware languages can consume them. Full stop. Conversely, if you make use of data types or programming constructs that is outside the bounds of the CLS, you cannot guarantee that every .NET programming language can interact with your .NET code library. Fine. That's it. Yeah, the common type system, that is CTS, continued. We are continuing our discussions on the common type system or CTS. The common type system, that is CTS, continued. In addition to the CLR and CTS/CLS specifications, the .NET platform provides a base class library that is available to all .NET programming languages. That's available to all .NET programming languages. Full stop. Not only does this base class library encapsulate various primitives such as threads, file input output, graphical rendering, and interaction with various external hardware devices, but it also provides support for a number of services required by most real-world applications. Full stop. Fine. For example, the base class libraries define types that facilitate the database access, XML manipulation, programmatic security, and the construction of web-enabled, as well as traditional desktop and console-based front ends. Fine. Full stop. See, that's it. For example, the base class libraries define types that facilitate database access, XML manipulation, programmatic security, and the construction of web-enabled, as well as traditional desktop and console-based front ends. Fine. Yeah, now what C# brings to the table. Now we are coming to the point of C#. So what C# brings to the table? Let us discuss that. C# is a programming language that looks very similar but not identical to the syntax of Java. It looks very similar but not identical to the syntax of Java. Full stop. Both C# and Java are based on the syntactical constructs of C++. See, both C# and Java are based on the syntactical constructs of C++. Full stop. Not only that, many of C#'s syntactical constructs are modeled after various aspects of VB6 also. See, various aspects of VB6 also. Full stop. Due to the fact that C# is a hybrid of several languages, the result is a product that is as syntactically clean than Java, and is as simple as VB6, and provides as much power and flexibility as C++. It provides as much power and flexibility as C++, full stop. C# provides the following features. C# provides a lot of features. We will discuss it one by one. 1. C# provides the following features. 1. No pointers is required. See, there is absolutely no concept of a pointer. No pointers is required. C# programs typically have no need for direct pointer manipulation. See, there is no need for direct pointer manipulation. Full stop. 2. Automatic memory management through what is called garbage collection. See, that's it. Automatic memory management through what is called garbage collection. Full stop. No need for the delete keyword. No need for the delete keyword. Fine. Yeah, what C# brings to the table continued. We are continuing our discussions on what C# brings to the table. So, what C# brings to the table continued. This is the third point, C3. Formal syntactic constructs for enumerations, structures, and class properties. Full stop. Fourth point. The C++ like ability to overload operators for a custom type without much complexity. Full stop. Again, 5. The ability to build generic types and generic members using a syntax very similar to C++ templates. Full stop. Then 6. Full support for interface-based programming techniques. Then seventh point. Full support for aspect-oriented programming or AOP techniques, programming techniques. Full stop. Via attributes. Full stop. This brand of development allows you to assign characteristics to types and their members to further qualify their behavior. Fine. Yeah, an overview of .NET assemblies. Here is an overview of .NET assemblies. Full stop. Regardless of what .NET language you choose to program with, observe that the .NET binaries take the same file extension as COMP servers and unmanaged Win32 binaries. That is star.dll or star.exe. Close the bracket. That is nothing but star.dll or star.exe. Close the bracket. But they have absolutely no internal similarities. Even though it has got a DLL extension or a .exe extension, they have absolutely no internal similarities. Fine. For example, the star.dll .NET binaries do not export methods to facilitate communication with the COM runtime. Full stop. Furthermore, the .NET binaries are not described using COM type libraries and are not registered into the system registry. Full stop. Perhaps most importantly, the .NET binaries do not contain platform specific instructions, but rather platform agnostic. That means one who does not know anything about platform. That is the meaning of platform agnostic. Means one who does not know anything about platform. Close the bracket. intermediate language or IL, and type metadata. That's it. See, perhaps most importantly, the .NET binaries do not contain platform specific instructions but rather platform agnostic, the intermediate language. That is platform agnostic intermediate language, or IL. In bracket I have kept IL, intermediate language. IL means intermediate language, and type metadata. Fine. Yeah, all .NET aware compilers emit IL. IL means intermediate language. Emit IL instructions and metadata. That's it. All .NET aware compilers emit IL instructions and metadata. Now look, when a star.dll or star.exe has been created using a .NET aware compiler, comma, the resulting module is bundled into an assembly. The resulting module is bundled into an assembly. Full stop. An assembly contains CIL, that is Common Intermediate Language code. CIL code, that is Common Intermediate Language code, comma, which is conceptually similar to Java bytecode. It is conceptually similar to Java bytecode in that it is not compiled to platform specific until absolutely necessary. Until absolutely necessary. Full stop. In addition to CIL instructions, Common Intermediate Language instructions, comma, assemblies also contain metadata that describes in vivid detail the characteristics of every type living within the binary. The characteristics of every type living within the binary. Full stop. Fine. Yeah, IL instructions and metadata continued. Intermediate language instructions and metadata continued. We are continuing our discussions on IL instructions and metadata. Fine. For example, if you have a class named sports car, comma, the type metadata describes details such as sports cars base class, comma, which interfaces are implemented by sports car, if any, as well as a full description of each members supported by the sports car type. Full stop. The .NET metadata is a dramatic improvement to COM type metadata. That's it. See, the .NET metadata is a dramatic improvement to COM type metadata. Full stop. See, the .NET metadata is automatically generated by a given .NET aware compiler. It's automatically generated by a given .NET aware compiler. Full stop. In addition to CIL and type metadata, comma, assemblies themselves are also described using metadata, comma, which is officially termed as a manifest. Full stop. It's termed as manifest. Full stop. The manifest contains information about the current version of assembly, comma, culture information, in bracket I have given, used for localizing string and image resources, close bracket, comma, and a list of all externally referenced assemblies that are required for proper execution. And a list of all externally referenced assemblies that are required for proper execution. Fine.